What's good, everybody? And as you can see, we have one in the shop that I'm actually really excited about. It's a Z, but not my Z. So here we have a 91 NA, and the issue with this one is it is not driving in any gear, reverse or any forward going gears. So we got it in the shop. We're going to follow a whole bunch of diagnostic procedures to try to figure out what is going on with this. This is a bone stock car, stock spec, everything except for these wheels. My understanding is that a new transmission was already done in this car in the past. So we're gonna try and take a step-by-step procedural approach to try to diagnose this car and fix whatever the issue is with it. We're gonna test solenoids, we're gonna pressure test it, we're gonna go through the work. So join us on the journey as we go and we dive into this. All right, first thing we're gonna start in the procedure is there's a drop-in resistor for the line pressure solenoid. So we're gonna test that out first. That's located inside this passenger side wheel well. So it looks like there's only 410s holding it in place and there's bolts missing. So I'm just gonna do it with the wheel on and not go through the trouble. So all right, so that rusty box you see up there, that appears to be the dropping resistor. So I'm gonna finagle my hands in there, take that connector out, and we're gonna get some resistance on it. All right. Yeah. All right, drop resistor ohmed out. So now we're moving on to the next step where we wanna, they call it in the factory service manual, the inhibitor switch, but it's the gear selector, right? All right, so this chart right here is showing us that when the car is in park, that you have to have continuity between pins 1 and 2 and 3 and 4. In reverse is between 3 and 5, neutral, and so on and so forth, you see. So I think, one of us, well, obviously one of us has to get in the car and put it in the proper gear, and then the other will test the continuity between the pins. Now, when we look at the next image, we see that here, it's about to get awkward real quick. So we have pins 1 and 2, right? And then on the other part of the connector, we have 3, 4, 9, 5, 8, 6, 7, and so on and so forth. So, and then you see how it goes from the gear selector or inhibitor switch, and then it comes off. So we are going to test the resistance between those points. All right, for reverse, I need pins 3 and 5. All right, so we're good there. For drive, we need pins 3 and 7. All right, go to drive for me.
Drive.
All right. All right, go to 2.
Yep.
All right, so for 2, we need pins 3 and 8. So 3 and 8. All right, so for 1, we need pins 3 and 9. Oh wait, hold on. Okay. All right, so we're gonna test part. Part is 3 and 4. Okay.
All right, so what we're gonna do is we're gonna check the line pressure solenoid circuit. The line pressure solenoid is inside the pan attached to the valve body. Now, the location of the harness it's connected to comes up here to the bay. So this is the one that went to the inhibitor switch. This is what we were just checking on. Everything was fine on that. This one goes to the solenoids. So back to the manual here. We're apparently supposed to check from ground what the resistance is to pin 1 on the solenoid's harness connector. So let's pull this out. And that right there should be what we're trying to check to ground. And the key is supposed to be in the off position to check that. Based on what we assume is a solenoid's harness connector, it should be the right connector in this diagram right here, this drawing. And if you look at this, I'm not sure if somebody moved them around at any point in history. I don't think you really can because of the wire length. But it looks like this is actually the connector we need. Just based on the way this drawing looks right here, we're supposed to have 8 spots for testing. And as you can see, the one that I recently just went over as calling the solenoid harness connector doesn't have enough spots. So I'm going to say this 8-pin connector is the one we're supposed to test, and we'll go with that because the diagram is showing us something a little bit different. All right, so we're checking resistance on pin 1 should be between 2.5 to 5 ohms. So pin 1 is the top right corner. And I'm just going to use the battery cable as ground. Should be the best possible ground we have. And it's not looking all that great. Okay, the battery cable is not the best ground we have. If we check the intake manifold, we're within spec, 2.5 to 5. All right, so to follow step B, we have to use the other side of the connector because as you can see before in step A, the top right was pin 1 and the peg is white. And now if we go down here, it's the opposite side and the peg is black. So that's going to be the side of this connector that we're working on. This is what we were testing before for our ground to the solenoids. And this is what we're going to be working on now. I had to unbolt it just so I could see the pins a little bit better. So that top left pin in there is what I'm going to be holding one of these probes on. And show us what we're working with in here.
All right, so see if I can hold the light and talk to you all at the same time.
You actually don't need the light, we're good.
All right. So when we hold it up this way, we see that we have all the blank slots on this side, right? Because you don't see anything pinned out here on the bottom, right? So that kind of tells me that these are like 47 and 48, everything that you were just shown on the diagram. So that tells me that 1 and 2 are gonna be up here, or 2 in particular is probably gonna be right here. It's gonna be my guess. So once we run that test, we'll know for sure.
All right, let's go back over here. Let me know when you're in pin 2 first, because that's step B. Sorry about the focus. All right, now let me get in here, and can't really see because it's so dark, but I am on pin 1, and let's see, we have 12.3 ohms, and we're supposed to have between 11.2 and 12.8. All right, so you can move over to pin 1 now.
All right, pin 1.
And we should have 0 ohms, which we do. So our power circuit is good. Okay, so everything checked out with the line pressure solenoid and the circuit. So we're gonna go to solenoid A and solenoid B. Now what we're gonna do is check ground from the solenoid itself in the transmission pan up to this harness here. So we're gonna do kind of both of them at the same time, the solenoid ground check. So this one is for B, and we gotta check pin 7 to ground, and it should be between 20 to 40, so that's gonna check the coil on the solenoid itself. And then for this one the same, 20 to 40, but it's pin 5 to ground. So let's run through that real quick, and then we'll move the video on to checking the power circuit side, which again is on this part of the connector, because this one goes to the transmission, this goes to the TCU. So we're going to check the power circuit together after the solenoid checks. And we're on resistance, and we'll just use intake manifold again, and 20 to 40, and we're at 23.6. And now for This is solenoid B. That was just solenoid A that I checked. Solenoid B, again, 20 to 40, 23.8. So we're within spec. All right. So now we're going to go through and check the power source side, which is going to be on this side of the connector, the side that goes to the TCU. And it's going to be pin 6 for solenoid A and pin 7 for solenoid B. And then on the harness side for the TCU, it's going to be pin 6 also. And what is this, pin 7? So they just kind of correspond with their numbers there, 6 and 6 and 7 and 7. Okay, so we're in resistance mode. Heath is over there on pin 6, and I am going to touch pin 6. I don't know if I saw actually showed you. Very cool. I'm on pin 6, and we have 0 ohms, which is what we're supposed to have. That just means the wire is continuous to the connector. So now we're going to move over to pin 7, which I am on in there. You're just going to have to take my word for it. And I assume you're on it.
Mm-hmm.
And we're at 0 ohms, meaning the wire is continuous, no breaks. So everything checks out with solenoid A and solenoid B on the transmission side and on the harness side.
All right, so I think at this point we've checked everything out electronically. We checked the inhibitor switch, which is the gear selector. We checked the drop resistor. We checked solenoids A and B, and we also checked the line pressure solenoid. So everything is within spec from that standpoint. So I think now we can transition on to the mechanical side of things, where we'll check the actual pressure that's going into the valve body. And if that checks out okay, my guess is that we'll put power to the solenoids to see if they're all moving, right?
Yeah.
Yeah. So, yeah, I think by the book, you saw us go by the book and check everything electronically. So now we just move on to the next phase. All right. Day 2. So as you saw before, we tested everything electronically, solenoid wise, drop resistor wise, and everything. So now we're looking to test pressure at this point. So there are 2 pressure points on the transmission. On the passenger side, there's going to be a 12 millimeter here that we're gonna test the forward going gears. So D, 2, and 1. So we're gonna go ahead and test that first. And then on the driver's side, there's the port that you test reverse. So we didn't take the exhaust down, so we have a swivel head on a 12. So we're gonna go ahead and take that out, get the pressure tester mounted. And all right, so here's our target bolt right there. All right, as you can see, I'll admit Ken did most of the finagling to get this thing in here, but all right, we're in our port and we have the hose ready. So now we're gonna drop the car a little bit. We're gonna start it up to get it at idle, and we're going to look for the pressures between 61 and 67 PSI.
So that's the transmission and drive. Put it in 2. All right. Put it in 1. All right. All right. You can put it in park and shut it off.
All right, so as you saw in all of the forward gears, D2 and 1, it was reading 60 PSI. So it's at the bottom of, or technically it's out of spec by 1 PSI, but it could be variance in our Harbor Freight tester. We don't know. So we're not even gonna bother testing the reverse port, but in case you were wondering, this is the reverse port right here, but we're not even going to bother testing it. because we're more concerned with the forward gears, at least at the moment. So we're not gonna go through the trouble. Maybe if we took the exhaust off, we would do it. But the next step, what we're going to do is we are actually going to take off this inspection plate right here to the torque converter. Or we're going to take the starter out. I'm sorry. We're going to take the starter out. We're going to take a look at the torque converter. And we're going to see if we see anything out of place there. And we're wondering, because the transmission was done on this car before. According to the owner, it was done 4 or 5 years ago. And then it sat for 3 or 4 years or something like that. And then they started driving it, and then all of a sudden died. So we're going to see if we can see a torque converter, if it's actually bolted in properly, or if, you know, the bolts may have walked out. We'll get hands on the flex plate or the torque converter. We'll try and see if we can move it around, but we're gonna take that step next. Then after that, if all of that passes, then we're gonna pull the pan and just go next steps from there.
All right, quick little PSA. These plugs are one-time use according to the manual. Only thing that makes them one-time use is they come with thread sealant on them, so put some on it when you put it back in and you should be fine.
All right, so we took the starter off and we tested the flex plate. Everything's attached. The torque converter is attached to the flex plate. That test did not yield any results. So now we're at the point where we are about to drain the trans fluid. We'll inspect that, and then we go from there. So we'll cut back once we get all the fluid drained.
So transmission fluid has been drained. As you can see, it is pretty clean. You can kind of see the top of the drain bolt right there, but it disappears within like 1/4 of an inch of fluid, if not a little bit less. So there's a lot of suspended metal in there. This is one of the magnets. Let me try to get it a little bit over there. One of the magnets, as you can see, it's pretty full of metal. It's got like 1/16 of an inch of metal on it. And if I wash it off in the fluid, nice swirls. So the fluid is not completely clean. I don't think the transmission's completely innocent in this failure. But I say we have a 50-50 shot that it's mostly the converter that's failed and the transmission might be good because it was recently replaced according to the owner, and I don't think we have a valid story on whether the converter was replaced too.
No.
All right, so we don't know for sure about the converter. Chances are it might not have been replaced. Yeah, so I guess we'll have to connect with the owner and see what he wants to do, but I'd give it a 50-50 that we put a new converter in it and maybe the transmission has other problems. Anything else? Any other thoughts?
Yeah, it's not the worst looking ATF I've ever seen.
But I can't say that it looks blameless in its condition.
Yeah, that's not looking. Yeah, there's metal for sure.
You can see for sure there's metal on that. So yeah, everything comes down to budget. This might be a do the work twice situation, and then money still isn't saved, but might be worth the gamble to save money and not replace the transmission. We'll see what's going on. Another PSA, don't use silicone on your gaskets. If you have a cork gasket, you can use gasket sealant, and it's kind of like a varnish smelling thing, but don't use silicone on gaskets. It just makes it worse. It doesn't actually help it seal.
Hence why you all saw under the car why the pen was so wet.
Yeah.